do it in ascending order. Okay. So given a unsorted list of array, what is the strategy or what is the technique we are going to follow to arrange them in some order? Okay. This is what we are going to study in today's session. Okay. So we have several sorting algorithms. Uh, okay, they are bubble sort, insertion sort, selection sort, quick sort, merge sort, bucket sort, and erratic sort. Okay. So we have the sorting technique can be divided into two types: internal sorting or external sorting. On how you're going to do the sorting, this is this is categorized as internal sorting and external sorting. Okay. So we will start with bubble sort today. Okay. Bubble sort is the very basic sorting technique. So in bubble sort is also called as sinking sort. Okay. So what happens is you will take adjacent elements, okay, and you will perform a comparison. So whichever is smallest, you will swap it. So this is the technique followed in bubble sort. It's very, very simple. You will be taking two adjacent elements and you will compare those two elements and will swap it. Okay. So take this example. So if I have a unsorted array 5, 1, 4, 2, 8. Okay. So now what I will be doing is I'll take the first two adjacent elements. Okay. So then I will compare those two elements. So the first element is greater than the second element. So I will perform a swap. Okay. Now I will take the next two adjacent elements and then I will compare. I will perform a swap. So next I will take the next two elements. I'll compare them and then I will perform a swap. Then the next two adjacent elements I will take. I will compare them. There is no need for swapping since 8 is already bigger than 5. So I will retain it. So this will be the output of your pass 1. Okay. So likewise, at every pass, you may have to find out whether the elements are in sorted order. So finally, you will be getting a sorted array. So at the worst case, what you will be doing is, if I have 5 elements, I need to do 5 different passes. This is the worst case. Okay. So this is the answer for my first pass. Clear? So now I will take this as the input for my second pass. So in the second pass, again, I will be comparing the first two adjacent elements. They are already in sorted order. I will retain them. Now I will compare the second two elements. Yes, it is already in the sorted order. Sorry, it's not in the sorted order. So I'm performing a swap. Then the next two adjacent elements, I'm swapping. So next two adjacent elements, I'm swapping. Okay. So finally, I will be getting this as the answer. Okay. So, but I won't be stopping at the second pass itself because I still doesn't know whether the array is in sorted order or not. Okay. So in order to cross verify whether the final output is in sorted order, what I'm going to do is I'm going to run the third pass. Okay. In third pass only, you will finalize whether your array is in sorted order or not. Okay. So again, I will compare two elements. Yeah, it's in sorted order. Compare two elements, it's in sorted order. Compare two elements, it's in sorted order. Okay. Compare the next two elements, it's in sorted order. Okay. Likewise, I will compare each and every element and then I will identify whether they are in sorted order or not. Yeah. So this will be the end of my algorithm. This is how we need to do. So at the best case, I will require minimum one pass to check whether my array is in sorted order. What will be the best case? You will be your input array is already in a sorted order. This will be the best case, right? So if your input array is in sorted order also, when you want to do bubble sort, you will minimum run one pass to check whether your array is in sorted order or not. Clear? So this is the working principle of your bubble sort. So we'll just see the algorithm here. So here what I'm going to do, I'm getting a input array. Okay. So then I'm having a variable called as swapped to check every time whether that value is swapped or not. Okay. This is a Boolean variable. Okay. So now I'm starting my algorithm. So the array index I'm taking. So 0 to the length of the array minus 1. Okay. So for example, in this input, it is just 5, right? 5, 1, 4, 2, 8. Is the blue marker visible, or you want me to change the color?
It's visible.
Okay. So this is the values. So now what I'm going to do, this is my 0th index and this is my final index. So till I reach this, I have to execute this. So every time I'm going to compare. So my A of 0 I'm going to compare with A of 0 plus 1, which is this is how I'm comparing the adjacent elements. Because in example, I simply said I need to compare the adjacent elements. So how I'm going to choose my adjacent elements? Like this. This step is for choosing your adjacent elements. Then I'm going to perform a swap. The swap function you already know, right? You can either do with the help of a temporary variable or without a temporary variable, you can perform the swap. So once if it is swap, you're setting a flag. Then you're going for the next two adjacent elements. Now my I value becomes 1 and I plus 1 will be 2. Likewise, at every iteration, I keep on moving the next two consecutive adjacent elements. So once I reach the end of the statement sentence, I won't be able to stop this. Okay, so I will be again executing a while loop. I'll again recreate a swap. Okay? So likewise, I will keep on repeating it. So when will it end? When all the elements are in sorted order, I will stop this particular work. That is when I have no more elements to swap. That's the purpose of this Boolean variable. So when I have, so what are you doing in your third pass? So I'm not swapping any elements. So there are no elements to swap. So my swapped variable is remaining as false itself. So when I don't have any more variables to swap, it means it is the end of my algorithm. So I am coming out of the loop. Okay. So this is the working principle of your bubble sort. Any doubts in this?
Ma'am, can you do in compiler once this one?
Compiler means like you want to execute this program.
Yes, ma'am.
We will do that in your lab class now. So in theory section, if you use online compiler, it will be difficult. In lab class, I will do it in online compiler. Okay.
Okay.
Are you able to understand this working principle? Or you want me to repeat this?
Understood.
Okay. So this is the best case and worst case. I told you, right? When I have n elements, for example, I have 5 elements as input. Okay. So even if I have 5 elements as input, all 5 elements, at least once I need to check whether they are going to or whether they are in sorted order or not. So at the time complexity for best case is order of n. Okay. At the worst case, what I will be doing, I will be comparing n elements. Okay. So for n number of times. So at the worst case, it will be n into n times order of n square. Okay. That is, I am going to take 5, for sorting 5 elements, I am going to take 5 different passes to sort. Then it means 5 into 5, 25. That's the meaning. That's how you're getting order of n square. Okay. So even though the working principle of your bubble sort is very simple, for larger arrays, the time required will be order of n square. So we don't normally suggest bubble sort for bigger arrays.